Now these are all bond energy values. Bond energy values means it's the energy, it's the amount of energy in kilojoules per mole required to break these bonds or to form these bonds. Okay, we're not looking at endothermic or exothermic here. It's just the energy here involved with these bonds. Okay, so if you're breaking the bond, it's going to be endothermic. If you're forming the bonds, it's going to be exothermic. But we're not going to go into these details. So these are all bond energy values. And when you look at this, so this is a single dash. So this is a single bond. Wherever you see single dash, it means a single bond. These are all single bonds. Whenever you see a double dash, this means a double bond. So here you have double bonds. And if you see a triple dash, it means that it is a triple bond. Now, the stronger these bonds, the higher the bond energy value. So you see a triple bond in nitrogen. This is much higher compared to a single bond in hydrogen, which means that a triple bond is stronger in nature compared to a single bond in hydrogen. You don't need to learn these bond energy values. Whenever you are required to use them, they will be given to you. Now let's see a first question. So you are given the bond energies for these bonds. You need to use the values given to find the heat change, the delta H, of this overall reaction. So delta H. So how do we find delta H? Delta H is, first you need to break the bonds. So whatever energy is involved during bond breaking minus whatever energy is involved during bond formation. So you just take the difference between the two values. Bond breaking minus bond formation. So let's look at the bonds that are being broken here. So these are called displayed formula. So displayed formula shows all the bonds in the molecule. So if you look at this, so the carbon is the same, hydrogen is the same. So we're not breaking these bonds, but this bond is being broken. So I'm breaking this bond here. So I'm breaking a CH bond. And what am I forming instead of this CH bond? I'm forming a CCl bond. So I'm breaking a CH bond, I'm forming a CCl bond. And what else am I breaking? I'm also breaking here a Cl-Cl bond. So Cl-Cl bond is being broken. And what am I forming instead? I'm forming an HCl bond. Okay, so I've seen what I'm breaking, I've seen what I'm forming. So now I'm going to compute the energy values. So CH bond is 412 kilojoule per mole. Cl-Cl bond is 242. CCl is 338 and HCl is 431. I will add these values. So here I have bond breaking. I will get the energy in bond breaking. Here I will get the energy in bond formation. I'm not taking any positive or negative values. I'm just looking at the energy involved during bond breaking and energy involved during bond formation. So delta H will be bond breaking 654 minus bond formation 769. Now when you look at the values, because the bond breaking value is lower than the bond formation value, so the energy being required to break the bond is less than the energy being produced when you form the bond, which means that the overall delta H is going to be negative. So you have minus 115 kilojoules per mole, which means that overall the reaction is exothermic. So this reaction here is an exothermic reaction because the amount of energy required to break the bonds is less than the amount of energy produced when the bonds are being formed. So because this is low and this is high, means that delta H is negative, then the reaction overall is exothermic. So it's pretty easy to apply in questions. You just need some practice.